Okay, I'm continuing with the schematics analysis of these 12AX7 tube-driven phono stages, the ear, 835, and the Hagerman cornet, and we are looking at the RIA correction, how it's done. So basically with the cornet, we had a total of a 10 kilo ohm resistance between the signal path uh, that has a relatively little impact on the sound quality because a 10k resistor and a 220 ohm resistor have relatively much lower impact on the sound compared to a 2 mega ohm resistor. So here this is it's kind of like a red light for me having such a high value resistor in the signal path. And the benefit that we get here is that we have direct coupling, but the direct coupling is not totally direct. It means that that part of the directness is true, that the plate here of this tube stage is sitting at the same voltage as the grid of the following stage. However, the electrons cannot flow freely between the two. And when we have direct coupling, the benefit is when the electrons can flow freely between the two. And there's a 2 mega ohm resistance between the two, so it means that there's a giant block that blocks the free flow of electrons, versus the cornet where we have capacitor coupling, but the resistive element is half a percent than what we get here. So 10k versus 2 mega ohm. However, here we also have a pseudo capacitive coupling because the 2 mega ohm resistor is paralleled by a small capacitor. So it means that the high frequencies here are getting through at a higher efficiency than than the lower frequencies, which are impeded by that 2 mega ohm resistor. So when we have high frequencies, then they can pass freely through that small capacitor, but when the frequency drops, then the lower frequencies don't go through that capacitor and they are forced to go through that resistor. And now uh, that's not enough to do the RIAA conversion. It will be finished by this feedback loop where we have a tiny capacitor, which means that it's letting to go through very high frequencies, and then it's series paralleled by virtually 800 kilo ohm resistance, two resistors in series, and 110 picofarad tiny capacitors. So again, we have a huge resistance here, which is not so beneficial for signal quality. And one thing that I have noticed that I can point out to you guys, that the ear, this is a very early design. It's, I think it's it predates 1995, and in at that time the quality of these coupling capacitors was not as good as we have today. And you see that these are the biggest value capacitor you have here. Actually, you have there 1 microfarad, but that's just the decoupling capacitor for the output. Here in the RIAA section, the biggest we have is the 0.5 microfarad. And that's because when you design the RIAA elements, then let's go have a look at the cornet. It's easier to show here. So let's take that resistor there. It's a 10 kilo ohm resistor, 6.8 kilo ohm resistor. Now, if we keep these resistor values low, 10 kilo ohm and 6.8, then we have to use bigger value capacitors, 47 nanofarad, 100 nanofarad. And when we keep the resistor value very high, then we will be using a 15 nanofarad and then just a few picofarads. So the total capacitances and the values used will be way lower, and that's the trade-off you have to work when you create your RI conversion, RIA conversion, is that you either using high value resistors and low value capacitors, or low value resistors and higher value capacitors. And nowadays, I would say that I would really go with this solution today: higher value capacitors and lower value resistors, because this is where you get the best benefit from current parts. While I have not built myself the ear phono stage, but I have built the RCA phono stage. And the RCA phono stage is operating with similar values like mega ohm range resistor, but it's used in the passive filter version. So the RIA phono, it does not use active RIA correction, it uses passive, but similar value elements that are used in the ear. And I have noticed that the cornet solution, because I have listened to them in parallel, as one would say, A/B tested them for many hundreds of hours. So I'm really intimately familiar by the difference that high value resistances and low value resistances give for the final sound. And by the way, the RCA phono stage also uses 12AX7s, but it doesn't have a cathode follower. So basically it's also an iteration on how to use 12AX7 for phono stages. And I think probably I can finish my little overview on the schematics. And oh, one more thing that I forgot to mention is that here we need to use the feedback loop for the active, because the active RIA correction means that we are changing the behavior of the tube to modulate, to get the RIA conversion. And when it's passive, it means that we have inserted capacitors and resistors between the two stages. And technically, when you read it in textbooks, there's a difference between the two, but practically it really boils down the same, because here we are using resistors and capacitors, and here we are also using resistors and capacitors. They are in different stages. They are fulfilling a little bit different roles, but they have the same electricity, the same signal flowing through them. And the problem that we get with the active that we did not have with the passive is that we have a feedback loop, and that causes a time constant problem. So it means that whatever is happening here with the signal, there's a time delay when it gets applied through the feedback. And I have noticed that applying feedback always creates a coloration to the sound. It takes away from a natural tonal balance. And if you have feedback or high amounts of feedback in your power amplifier, then this, sorry, what did I do? Then this feedback loop here might not be bothersome for you, or you might even not notice what it is doing. But when you use no feedback amplification, then employing a feedback loop in a phono stage will cause a clear change in character from a natural tone. So I hope this is useful for everyone, and I hope with these advices you can improve on both of your phono stages. And even if you have none of these phonos, you have different ones. You can apply what I said in this little series to any phono stage, basically. Have a wonderful day. Please like and subscribe. Share your experiences. Bye bye.